Welcome back. Thank you, Tyler, for that intriguing presentation, thought-provoking, as evidenced by the number of great questions that were asked. Note for everyone, if you'd like to reach out to Tyler directly for additional questions, if you have them, please feel free to reach him through the platform. You'll find Ask Him a Question button under his bio. Now, I'd like to introduce the next presenter from the University of Sydney, Dr. Dennis Ferrer, PhD graduate. He will be discussing an agent-based simulation exploration of satisfying behaviors in a complex financial economy. Welcome, Dennis.
Hello, everyone. As suggested, I'm looking at satisficing behaviors in a complex financial economy as part of a PhD I completed in 2020. It's an interesting journey, so I'd like everyone just to join me on an exploration of how economic theory develops into a very unorthodox approach that I've done for my PhD in AnyLogic model. So there are 5 sections, so I'll talk about my journey. I want to explore the theory framework, then I'll go into my design, I'll do a simulation execution, and then we open for questions. What I'd like to talk about first is it's just some of the interesting stuff that I looked at from a theoretical perspective. I looked at a synthesis of 3, heterodox economic theories. One is on economics and 2 behavioral theorists, and putting into an economic model that to better comprehend the role of decision making under uncertainty. It's bound by time and uncertainty and risk. And what I found, especially in the economic region, is that we fail to look at other tools and abilities that allow us to, better explore the role of behaviors in economics. And some of the stuff we get trapped into in the economic discipline is that we fall into what is known as dynamic stochastic general equilibrium models. They're very system dynamic based. And a lot of the tools that we choose, because we're academics, free is better than paid. And so often tools like AnyLogic get overlooked from a cost perspective, particularly in my experience for a number of years. And also, there's also a significant trade-off. There's a bit of an ego trap because we tend to want to own the research beginning to end. So from my perspective, I chose the AnyLogic platform more in the sense of that it's more of a high degree value proposition. I'm not a programming expert by any stretch. I started this in 2014 with zero knowledge about how to use this platform. And where I found it useful is that a couple of key things is the value of the tool, the ability to visualize outcomes. I could become moderately proficient in growing my skills over time with making a ton of mistakes, and also be able to create and manage data. I looked at a range of tool sets. Things some are listed that are known or unknown. NetLogo and StarLogo are quite often used in economics, but they hit their setting very quickly. And also these other Java-based tools and C+ tools. I've got Repast, Flame, Mason, Jaml. And these are things that I've discovered back, you're talking about 6-7 years ago. I started looking at this tool set at 6.5. So it's been quite a number of years for me to get onto this journey. But I chose that AnyLogic because it really appealed to a couple of things that you'll see as I'm going through the theory framework. It's dealing with highly complex agents with decisioning capabilities, and something I could not find in other platforms. So what I'll do, let's take a journey through this. I'll talk through some of the, these are the academic views of system modeling in general. So in economics, we tend to not use these type of tools. So even back in the 1950s, we recognized that we do need to look at things that give us greater insights. In doing so, and Simon has got the quote there, in doing so, Simon looks at some things like, even though we've got these tools, we don't have to solve the world. And in economics, we tend to want to prove we've solved everything before we actually get a result. But this is a whole experimentation engine that looks at there's an option for us to do and look at more complex things. So I'm going to take you through these couple of bullet points about theory. And the reason why I need to do this for you is that you can start building the linkages between the theory and you can start seeing the agents and the roles they play in the system. So the theory, what it looks at, this is a financial instability hypothesis. It's by Hyman Minsky. He describes a couple of things, 7 key elements. There's a system with a past, so there's history. There are decision makers with experience and expectations. They realize their expectations against actual events. And these drive a couple of states. So this is state-based concepts. They've got things like hedge, speculative, and Ponzi. And these are about the degree of leverage a economic decision maker would make in a system. And so they go through a cycle of making their expectations meet their actuals. And as a result, their behavior then drives price movements into the system. 2 things, asset prices and investment goods as per the theory. And they tend to escalate through the system as expectations and reality tend to feed onto each other. So that you can see there's a feedback loop effect happening. Then we have an alternate agent in the system that does a evaluation of these expectations as there's a handoff between 2 sets of agents who come to a decision-making process. Sort of like saying, is this a good bet of your decision? And as things rise and things escalate, expectations don't necessarily meet actuals. And so the system then goes through a downward cycle. So you can see now we're talking about upwards and downward cycles in the system. Then the system perpetuates and the waxing waning expectations and to drive these deviations. Now I'm going through the behavioral side. So we're going through the macro broader aspects. Now we're going through the agent, the specific decision-making aspects of it. So there's 2 sets of authors. So I'll go Herbert A. Simon. So he looked at the choice of satisfactory outcome. So this concept of satisficing behaviors. There's a few attributes. So talking about time is a very important aspect. The choices are not optimal. There's processing of the decision is modest, so we can't process every single outcome. Information incomplete, and the future is unknown and uncertain. And we generate prospects. That's the term used for decisions based on the information we're given at a point in time. Just one more slide on this. So then we go to a second body of thought that look at identifying the choice, how it's derived. So on the left-hand, on the right-hand side, you see a little diagram, the A, B, and C. So A is the expectations, how we derive the expectations. So this is where the agent goes, well, how do I come to a decision-making process? And more importantly, overlaid by risk. And then finally, it talks about system 1 and system 2, which is a very interesting concept where it represents 2 polar opposite things. System 1 is more of the emotional, immediate response. System 2 talks about error correction and more deeper thinking. So the interplay of emotion and judgment come to a decision that's made in the system. So this is a diagram of the synthesis of the 2 ideas, and I guess this talks on the left-hand side is the decision-making cycle. So expectations is really what we like to talk about in the theory. So where I've got these highlighted red balloons this is what drives the decision-making process. Subsequent to that, it drives economic outcome. So it's interesting to see the interplay of the 2 theories coming together nicely. And on the right-hand side, this is when you start to see economic cycles occurring. Now, in the theory, it talks about, typically we have in economic theory, we always have a worker, a producer, a government, a central bank, and a market. Now, I've taken a little bit more of an unorthodox approach, and since I can't solve for everything, going back to Simon's comment about what are we exploring and what do we want to achieve, I've aggregated some of the roles, and you see this is where I start to develop agents in the system which have a bit more of unique properties. So the economic agent, which I've claimed, does a whole bunch of things. It consumes, it makes decisions, the savings, investment, it reacts. The central agent looks at the things that we typically think as a producer, does employing of labour, pays of unemployment benefits and things like that, does automatic stabilizers in the economy, derives interest rates as well. Then I've got financial agent, which is, I guess, the stock version of the bank, and an asset market. Okay, so this is where I start going into the design. So That's the theory. Now we can start making the linkages between the theory and the design. So a couple of things is with the environment, what I've focused on. So we've got endogenous and exogenous system activity. So agents do determine their own destiny with system shocks. The data is theoretical, so the difficulty with in economics, they always say, where's the evidence, where's the real world? The problem with that is it contains us into exploring very limited streams of outcomes. So based on the theoretical constructs, we can start looking at creating a whole bunch of potential outcomes and see and test. This is what this platform is beautiful for. Time and history, it's not turn-based, it's synchronous and asynchronous events. We do have double entry accounting, so that's all fully reconciled. We do make conscious decisions that there are leakages in the model. This is not perfect, and the model is never supposed to be. It's supposed to be exploring behaviors. I do have a fixed population with infinite lifespan, so I'm not looking at a life cycle of an individual from birth to death. The agent is more communication based. I don't have to deal with spatiality, so unlike some of the models that we see, about distance and spatiality, which are just completely fantastic in how they've been developed. Luckily, I don't have to deal with that. This is not the intent. In trust and reputation, we skip that by, I'll explain in a moment, by system 1 methodology, which is the consuming of information. And I use state very heavily, and I'll explain what that means in a moment. State's not a binary attribute. These are a design of the attributes of the agent. So I'll call these in tiers. So my key ones are my economic agent, my financial agent, the central agent. These are the primary drivers of the system. I have tier 2, which are non-behavioral style agents as a store of value, and tier 3 are transactional agents, which I find fascinating, especially with exploring some of the models in the AnyLogic library, where we can use agents as disposable attributes, consumed and destroyed over time. So here I've got the view of the economic agent, and this is the sort of flowchart sequencing and design format. It is the center of the universe. It looks at, it comes from the decision-making process. So it has a decision engine. We're going from A to B. So it receives inputs, it defines outputs. As a result of outputs, it then attains a state, which is, I've got very simple states of positive, negative, neutral, just to make things easier. However, it's got strength of state. So I may have a positive, but a very strong positive or a very strong negative state that we use. And system 1 and system 2 work in intent. And also we look at reasoning. So the intent and reasoning components are a lens that are used through this whole system for all agents. So the intent is then to drive its actions in the model, whether I invest, whether I consume, whether I take on additional leverage, and external events such as being unemployed, whether I then subsequently consume signals from other agents and start to consume those type of attributes. The system 1 and system 2 blends, system 2 acts as a veto for system 1. So the intent may be vetoed by some more reasoning, but depending on the strength of the intent. Also, just very briefly, there are sorts of policy decisions that happen with also in the agent. So we set policies as handbrakes and accelerators. So if it recognizes something, it may overrule its current system 1 and system 2 to say I'm going to do X versus Y. And two of the things I've got colloquially standard is if I see an asset market being heated or asset market in a lull, I'll go through, okay, this is too good to be true, so I'm not going to send messaging out, or vice versa. This is a view of the sequencing that I'm really focusing on with the agent simulation decision-making process. So it starts with messaging is the most important piece of information it receives. It then looks at distinct values. So if the most distinct value is one by message, it will attain that message as a state. So if I've got a very strong view of positive, it will attain a positive state, and so on and so forth with neutral and negative. However, if it's not a strong signal, so there are acceptance criteria built in, it will then look at other things that are weaker in the model to then make further more decisions. So it looks at the state. So it looks at the connected population that it's included in. And it says, well, if message is not good, then state that I'll look at. If state is not good, then I'm going to look internally to my history. So my past historic decisions are then a next barometer for my next state. So I look at short-term history. Short-term history is not good enough. Long-term history. Long-term history is not good enough. I'm not making a decision. So I retain my state, and then the cycle then continues. Once a state is attained, I mentioned these levels of very high, moderate, and very low through the 5 states, and it then drives my outcomes, whether I consume, whether I invest, and so on and so forth. State is also internal function, so it erodes over time. So the one really key thing is that even though it might be positive, very strong, this drives how I message my population, and subsequent to that, it erodes over time. So a very strong state means I will communicate for a longer period of time, but if it's weak, then it's a very short period of time. Then I'm open to other signals to change my state. And this is just a quick screenshot of how the detailed model starts to pan together. It's driven by overall a number of state charts. It's about 6 or 7 state charts in the system. And also there's a lot of algorithms that will do process matching. So system 2 will be processed in the background. System 1 then tests against system 2 and overrides as we go through it. A summary of what we'll see in future, and when I run the simulation as a bit of a video, we'll go through how this starts to look like in the AnyLogic model. And these are the other agents that we start to work with. So we've got now my system of asset market, and we use as a clearinghouse. So matched orders, buy and sell, come through, and then it will generate a price. If there's no orders, then the timing of the order that will start to decline, and then the market will just match it just to get it out of the system. Then we've got the asset agent, which also acts as a portfolio. So I've got transactions in a collection, and the collection then gets iterated over. Then we get a view of what that asset portfolio starts to look like. And again, just a quick screenshot of what that would look like when we show the model. The asset agent itself, just a quick screenshot of what that starts to look like. We've got 3 other additional disposable agents as such: the asset buy, sell, and transaction. Transactions is retained for a bit longer as it's retained in a collection. The asset buy and sell is basically disposed with a few values that are sent in the asset market. Financial agent, again, we use a lot of the creation and population management components of it. Here, the financial agent really looks at policy, looks at the attributes of the EA, the economic agent, and says whether you're good for it, looking at their asset portfolio, equity, their financial state as well, and it looks at the overall aggregate of the system. Just a quick screenshot of what this will start to look like as we will look through the demonstration. And lastly, we've got this overall controlling central agent, which facilitates a whole bunch of things around production, employment, payment of income. It looks at interest rate determination. It looks at lender of last resort. Some of the things we talk about in the economic theory, and also sends messaging to the agents in the system. Much like I failed to mention the asset market, 2 things that these 2 agents particularly do is they tend to shape emotion. So they will send signals irrespective of the actual situation and start to shape the agent population and see what they're going to do. In the execution, this is just basically a view of the simulation setup. So in the PhD, I looked at 26 individual conditions, 78 different options. So the permutations are quite extensive. The key things I was really looking at in my research and the outcome I was driving for is to look at a couple of things. Perfect information, which is where I assume that if a fully connected population connects together, they know everything about each other and they act accordingly. Policy, whether it's strong or weak, and also just a generic example to then match against to see whether there's any key deviations that we can learn from. And I ran 72 iterations over 18 different scenarios. At the time when I had my PC, I was only able to run at 50 agents. As technology progresses, it's much larger. For the purpose of today's demonstration, I was able to run 250 agents with a baseline income of 50,000 and assets of 50,000 per unit. And you'll see how this starts to flow through when I do run the model now. So I'll just run the simulation for you. Okay. So what we can see, if I just pause for a brief moment, I'll get my little laser pointer out. I'll let that run for a little bit. What we see on the going from left to right, now we start to see in the top left-hand corner, we see the agent's emotional state and at aggregate level. So we see the red is the negative, green is the positive, and the yellow is the neutral. These are the aggregate messages being received in the states that are being attained over time, their strength. A little bit below, we start to see the count of states. Then we see the count of the the consumption states in total. So we've got what we can see from the aggregate. Laser pointer. In the middle, we start to see the loan values. So we can see the amount of leverage being taken in the economy. You've got the debt to income ratio starting to come through. So we can see some of the macroeconomic aspects being driven by state and emotions on the left-hand side. Then we start to see the economic agent asset values. Here's the market. So we can start see the queues being generated of buys and sells in this middle component and see the structure of the market matching off the orders. We see asset price and history also being generated by the model to be able to give the economic agents also a view of potential outcomes which it could consume. So I pre-process a lot of this information to allow the agents to consume without having to do too much processing itself. When I go to the next stage, this is now the asset agent themselves. So this is the financial agent, sorry. And this is looking at the loans processed by the agent and also the aggregate financial state. So you can see it gets to a speculative state quite quickly. It will generate policies. We're looking at the interest rates being generated. We also look at the money supply being generated as well. We're looking at the central agent here. This is where we've got generate interest rates, employment, and some of the messaging. So I'll pause this for a moment. In this component here, we can see over here is the messaging that's being sent by the central agent to influence outcomes of the EA population. And as it moves to the last piece, and we look at the economic agent directly. So this is how the economic, I'll pause this quickly. So this has been running for probably a couple of years, about a decade or so. We can see the economic agent generating its states in the top right-hand corner. Looking at its projection capability. So it starts to look at how it's projecting market prices. The top is all the dashboard about where it's at any point in time. Its loans, what it's doing from a leverage perspective, and starts to make decisions based on the system 1 and system 2. So and also we look at, it's on the right hand side here, the system 1 and system 2 variables. So system 1 is basically looking at the intent, and the system 2 is the governance of the actions that the agent is undertaking. I think we get to a more detailed view in a moment. Now we look at the linked asset agent shortly. So when we see the linked asset agent, it's also a population base. So I'll be cycling through, also this is cycling through some of the agents, so you can see a demonstration of agents in various states and what they're consuming over time. When I go to linked asset, going to this is the detailed view of the engine underneath, or the decision-making states that it's making, and the further detailed view of additional algorithms and history that's consuming and reacting with. Pause this quickly. These are all the reaction algorithms in states. So it consumes a whole bunch of attributes that are pushed into these state charts and then subsequently pushed out into the agent decisioning engine. The asset agent has action as a portfolio, a collection of asset transactions. So we can see its history of an investment proficiency, profit high and profit low. We'll cycle through a few of these examples as we're doing now, just to see that the asset agent, they're connected directly as a relationship to the economic agent, and we can see what it's doing with respect to consuming and calculating its state. Then we're going into a loan agent, which is fairly unexciting compared to the rest, and this just holds all the loan attributes. And what it tends to do is then to look at also the payment history and default logic as well. So there's an opportunity for the system to stop the agent consuming or investing if they're going overboard. And this is basically starting to see the agent, the market cycle. I'll just show you quickly. We can see debt to income ratios rise. We can see how the market starts to get volatile. On the right-hand side here, we can also see some of the policy stuff floating through about whether it's good enough or too slow in the market. That's the agent population doing two things, acting or messaging. And we'll also see the asset market in this portion here messaging out, as well as the central agent also messaging out some parts of the aspects of the decision that they'll make. And we see income distributions, we see interest rates, and then we can see some of the financial asset states and of the actual financial agent itself. So it really, what it basically came down to is, I think this is just about to complete itself. So some of the things that we found through this process is through rational expectations as a definition of saying that we can make decisions based on all information and be able to extrapolate over time. But given I can connect agents into the system and also demonstrate that either through 100% connectivity, it's a fairly sedate looking view of the market, but when we disconnect ourselves, we tend to be more volatile in our approach. There is a policy influence, so if I was having more stringent policy, I tend to also be able to define the agent behaviors, which I found that more strict policy, especially with lending criteria, enabled the agents to behave in a certain way, which meant the market was more stable. Also, liquidity drove the market in the sense of equity. So if I use asset equity, I was able to define that having more liquidity drove more volatility. And also some of the interesting things I didn't expect is system crashes were averted by cash being generated in the past. So I was expecting in my system dynamic models to see massive swings and crashes, but I found there was volatility more driven by leverage, but I didn't see a crash per se because everyone was using cash in the model. Some of the quick things that I found through this process, it was too complex where I learned from, and there's a lot to learn. So there's the things that I did appreciate that was, there's still a lot to go through, and I think in the next iteration we'll be able to look at something that's far more robust. Thank you.
Thank you, Dennis. Greatly appreciated. It's great to see, and we appreciate you sharing your very complex model. And it's great to see a good use case in the financial context, which is very rare with AnyLogic. And again, thank you very much.